All right. So yes, I was saying that the cut, we are going to let's shift it from 1st December, which is a Wednesday, to 3rd December, which is a Friday. And also the assignment, instead of handing it in on the 3rd, you can hand it in on the 10th. Okay? On the 10th. Yes, that's what I'm, Andrew, yes. The assignment, let us hand it in on the 10th of December. So that's, yeah, I think that will be fair. And I've not yet gotten the full list of people who are taking the course, but Davis is going to give it to me today. He said he's going to give it to me today. Right now, you're supposed to be doing groups of 5 for the assignment, but then depending on the number of people I get, then I'll change the number of people per group. Okay? But for now, you can hand in, you can hand in 10 to meet me. That will be a physical lecture. If we have it's your choice. If you want to hand in via email, that's okay. If you want to hand in physically, that's also okay. Okay. So really, it's your choice. Any of the two will do for me. I sent Davis the other part. Okay. And today's PowerPoint is different. Today we're going to look at validation, safety critical systems validation. Okay. Okay, today is I'm just going to open for you the PowerPoint so that you can have a look. So it's actually a PDF, this one, although it looks like a PowerPoint. Okay, so today's lecture, okay, I don't know. I hope we can, and I'll see how quickly I can finish, because I have some students I'm supposed to check on that I'm supervising. Let me see how quickly I can finish. Finish quickly, it's okay. I'll see. Okay, so yes, I'm not reading. Which email should we use when you're handing it in? Let me just type here my email. Dot Nyamutale. Ignatius.nyamutale@gmail.com. Okay, so that's the email address that you can use. That you can use. I think you've also seen it. Okay, I believe you our topic is critical systems validation. Look at particularly this division of them: reliability validation, safety assurance, security assessment. Okay. So first of all, the definition. Defining it, there is the same word, which I don't advise: validating the reliability, safety, and security of computer-based. Just a proper definition for validating, otherwise we won't be defining it. So instead of using validating, you could just use, let me just check here in my notes. Okay. So yes, hold on, I'm trying to check in my notes here. Okay, so instead of just a matter of replacing the meaning of the word validate, okay, which is as long as you use proper wording, to check or prove the accuracy of something. So checking or proving the accuracy of the reliability, safety, and security of computer-based systems. Okay, that's the critical systems validation. Yeah, and so we're going to be looking at. And we have 3 validation perspectives, among which we have reliability validation, okay, which answers the question that does the measured reliability of the system meet its specification? Okay, because there are 2 things. There is the specification of what the system is supposed to do, but then there is, does the system meet that in terms of reliability? Okay, is the reliability of the system good enough to satisfy the users? Okay, safety validation. Okay, speaking of reliability validation, there's the company I was working for. So we had to install licenses. This is how some of these licenses work. Network, and then maybe there's a future. Is a future which at the same time as being able to use your data simultaneously. So some of these features work together with licenses, and once to buy a new license. Okay. So some of the licenses that we were installing, actually, they had some loopholes. It happens really for every company. They had do 100% of some things. However, they met all the specifications that were given. Okay. I don't remember if it was Orange or MTN, but they were meeting the specifications, those licenses. So you can see, as long as the specification was given to you is being met, okay, in terms of the reliability, okay, in terms of the safety, does the system always operate in such a way that accidents do not occur, or that accident consequences are minimized? Okay, also even security validation of the system and its data secure against external attack. Okay, there's some of these can really be tricky now, like safety validation. Because for safety validation, first of all, it's really crucial, because if an accident is to occur, it can affect many people, and that would be a problem. Okay, safety validation is also crucial because it actually gets into software engineering ethics. Okay, so some of these we cannot go into deep detail, but some of them have deeper significance. than the other. Addition, you just and okay, we're not going to the topic of software engineering ethics, although it's quite an interesting topic as well. Because for software engineering ethics, when it comes to safety validation, they give an example of a scenario. Imagine a difficult situation for professional engineers, which arises when their employer acts in an unethical way. For example, if a company is responsible for developing a safety critical system, and because of time pressure, it falsifies the safety validation records. This is almost similar to the example I gave you at the beginning of the Boeing 7. Okay. So in this scenario, you wonder, is the engineer's responsibility to maintain confidentiality, or to alert the customer, or to publicize in some way that the delivered system may be unsafe? Okay, and as I'm saying, it's very similar to the example I gave, because one wonders, so the few engineers who noticed what Boeing 787 was doing, were they supposed to come out? Okay, these are some of the questions. I'm just doing a sneak peek into software engineering ethics. Okay, it's also quite an interesting topic. You could read about it really on your own, but it's not something which I'll examine. Okay, so the problem in such a situation is that there are no absolutes when it comes to safety. The system may not have validated. Okay, these criteria may be too strict. So some, such that even if they're not all met, a system may actually remain working safely. Okay. So in such a case, the question is again, what's the response of the engineer to the employer? Okay. Well, is it the engineer's responsibility to maintain confidentiality or to alert the customer? The problem is, I said that there are no absolutes. Okay. This is safely through its lifetime. Okay. It is also the case that even when properly validated, the system may fail and cause an accident. So remember, even if it goes through all the levels of validation, it's not 100%. We're human beings. Okay, we're human beings. It's the system is not 100%. It's like how there's no human being who has not sinned, and there's no human being who does not sin. Okay, so that's the same thing. So the same with these systems that we make, there is also no way that you're going to be 100% sure that there will never be a problem with it. Okay, of what the employer is doing may result in damage to the employer and to other employees. Okay, yet it may not have been necessary. At the same time, failure to disclose the problem happens because of what they are doing. Okay, so in this case, they advise that you must take up your own mind, okay, in the matters. The appropriate ethical position here depends entirely on the views of the individual. The extent of the damage and the people affected by the damage should influence the decision. If the situation is safe, the rights of your employer. So if it is really dangerous, it is only ethical to go ahead and publicize it, but in a way that respects your employer. Okay. Otherwise, if it's not something which is dangerous, sometimes it may not be necessary to go ahead with it. Okay. Those are just some tricky areas to do with software engineering ethics. Okay. That was really something you can dig into, because you'll come across those circumstances. You will come across them as you work. You'll be at points whereby, okay, can I do this? Am I supposed to do this? It is tricky. And the people were stealing fuel. But then you wonder now what what happens? Do you put them? Very, very tricky. But I was the one managing the levels of fuel that were remaining in the generators on different sites. Yeah, so of course I couldn't allow the wrong fuel levels to be recorded, but it frustrated the rest of the team, and which another job somewhere within the same season. So these things can be dangerous. Okay, validation techniques. We have different validation techniques. We have static techniques, which we shall look at today. The dynamic ones we shall look at in the next session. So among the static techniques, we have these. We have different ones. We are going to look at them. But then they just talk about they involve design reviews and program inspection. They also involve mathematical arguments and proof. Okay. The dynamic ones involve statistical testing, scenario-based testing, and runtime checking. Okay. Main processes that minimize the chances of process errors that may compromise the dependability of the system. Okay. But yes, techniques. Okay. So I may not. I will be using other references as well. Not everything will be here that I talk about, but really for you you'll understand better. That's the most important thing. Okay. Okay, so static analysis techniques. Static analysis techniques are system verification techniques that don't involve executing a program. Okay, unlike dynamic techniques can be used to check the specification and design models of a system to pick up errors before an executable version of the system is available. So you can see here, it's before an executable version of the system is available. Okay. So they just also explain that they're concerned with analysis of system documentation. So this is all being done before the system is executed. Okay. So it's concerned with finding errors in the system and identifying potential problems that may arise during system execution. Okay. So all this is being done before. Okay. And the documents may be prepared to support the static validation. Okay, that one is okay. So static techniques for safety validation, still it's just a continuation really. Demonstrating safety by testing is difficult because testing is intended to demonstrate what the system does in a particular situation. Testing all possible operational situations is impossible. That's one downside really of static validation. You're not going to be able to test all scenarios because once it's operational, once it's executed, a scenario can happen that of whose variables you did not calculate. Okay, it's very difficult when it's so normal reviews for correctness may be supplemented by specific techniques. Situations never arise. Okay, that's really just for the explanation. But then for this, for the safety, sorry, for the static analysis techniques, there's what they call static analysis so much here, but in the textbook that I shared with you last time, you will come across them. Okay, static analyzers. We don't have, let me see if I can quickly find the page. Static analyzers. Okay. Okay, so there is this other one called Chapter 12, Safety Engineering. I also shared it with you. It's called Chapter 12. That document is called Chapter 12, Safety Engineering. Okay. So in Chapter 12, Safety Engineering, on page 22, they talk about static analyzers. Automated static analyzers are software tools that can scan the source text of a program and detect possible faults and anomalies. Okay, so we have static analyzers, and those are amongst the static techniques that are used. Although there are other static techniques. The additional static analysis techniques that may be used. Okay, others include, one of them is my screen sharing. Verification, which is, okay, let's first leave the safety reviews. We talk about it, it's just mentioned later. Yeah, it's there. One of them. Then we also have model checking. Model checking also you find as well. Okay. Then also automated program analysis. That is actually the automated program analysis. Because that's another one. Yeah, another one is automated program analysis, where the source code of the program is checked for patterns that are known to be potentially erroneous. Okay, so you'll find that. Okay, no, that's actually the one of static analyzers. The one of automated program analysis is the one of automated static analyzers. Okay, so those are three methods which are actually static analysis techniques, not dynamic, because they are done before the system is in execution. Okay. Okay, so they also have the advantage that the presence of errors does not disrupt system techniques. Okay, when you test a program, defects can mask or hide other defects, so you have to. I want you to just note that there are those three static analysis techniques. Okay, formal verification. Okay. So, okay, I know here they first go into safety. I want to go back up there into the safety research. Don't mind about that. I'll go back to them. Let's first talk about the formal okay. Model checking. Yeah, that's where a theory improver is used to check a formal description of the system for inconsistencies. Okay. So model checking uses theory improvers. Formal verification uses mathematical arguments. Then the static analyzers, I already talked about those ones. Okay. So that's really we are in the static analysis techniques. Okay, so the formal verification is actually really used a lot. Okay, the development of critical systems is one of the success stories for formal methods. Formal methods are mandated in Britain for the development of some types of safety critical software for defense applications. Okay, and formal methods, they are actually also used let me just check right here. Routing protocols, security applications, and operating system microkernels. So they're actually, and it has been success, and formal verification has been frequently used in hardware by most of the well-known hardware vendors like IBM, Intel, okay, AMD. Their product. So these are actually common methods that are used, okay, formal verification, because they are tried and tested. They are tried and tested. Okay, so formal verification includes specification validation, okay, where you develop a formal model of a system, developing a formal model of a system requirements. Specification forces a detailed analysis of the specification, and this usually reveals errors and omissions. This also discovers specification problems, and then they demonstrate that a program or a design is consistent with its formal specification. So they're just talking about what is involved in the formal verification methods. Okay, so we have there's some disadvantages of formal validation of this. Even in the textbook, they talk about them. Let me see if they do talk about them here. Page 14, I think. Okay, remember, if the time is up, you just have to reconnect to the same link. Page 14. Okay. I don't see it here. Okay, I don't see it specific being talked about much in the. So the formal model of specification is not understandable by domain experts. It is difficult or impossible to check if the formal model is an accurate representation of the specification for most systems. Okay. And then another disadvantage is that verification does not scale up. Verification is complex, error prone, and requires the use of systems such as theorem provers. Okay. The cost of verification increases exponentially as the system here, but then some of the ones that I came across for the limitations of formal verification. Okay, errors in specification is one. Please, you can note that errors in specification, although it's similar to the first one anyway. Okay. Error is missing specifications. So the specification that you're using as a reference may have a bug. Okay, so that's what they mean by errors in specification, and that explains actually the first one here. Okay, the first point there. Okay, then we can also have incomplete functional coverage of specifications. Incomplete functional coverage of specifications. Formal methods verify properties. Okay, formal methods verify properties that of course can be specifications. In practice, however, it is rare that all specifications are given to a formal checker on and once all the specifications are not covered, then definitely you're not going to be able another disadvantage of formal user errors. Example user errors are incorrect representation. Remember, it is human beings who are making these specifications. Okay, so they can also make errors. Okay, and the fourth disadvantage is formal verification software bugs. Okay, bugs in formal verification software can misdesign errors and thus give false confirmation. Okay, so remember, any kind of program is never perfect. Okay, any kind of programming. Now I'm talking about the program itself, the software itself. Okay, it can have bugs. Okay, I'm not talking about an error in the specification. I'm talking about this, the formal verification software itself having a bug. Okay, there is no guarantee for a bug-free software program. Okay. Let me see if I can just post this. Just a second. Let me see if I can just post those disadvantages. Therefore, I'm trying to see if I can post the disadvantages on the chart there. Maybe easier to pick them up. Okay. Let's see. Okay. That was the first disadvantage, which was explaining the same as the one that we have in our PDF there. Okay, yeah, so those are the ones which I was talking about. Okay. But then they give an extra one here. Okay, the second one here, verification does not scale up. That's another one. The cost. So you have systems that are really big. Some systems are smaller, but you have systems that are really big. Okay. Initially. Okay, so that does not scale up. That means that as it is. Okay, so those are the disadvantages of these formal the formal methods. Okay. So just a conclusion really on the formal methods. Advantages. Okay. The advantages of and an understanding of the software requirements and software design. Okay. These are mathematical entities and may be analyzed using mathematical methods. Okay. And then also formal specifications may be automatically. Okay, so those are some of the advantages of the formal methods. Okay, so you just, I can see there's just less than 1 minute, but you just connect back onto the same link. Okay. I'll just wait for it to go when you connect back.